Welcome back to Ocean Week. Today we face the ocean's ultimate fury, the tsunami. Imagine this. You're standing on a beautiful beach, watching gentle waves lap against the shore. The water is calm, peaceful. But thousands of miles away, something catastrophic has just happened beneath the ocean floor. In the next few hours, waves traveling faster than a commercial jet will transform this tranquil scene into one of nature's most devastating forces. We'll uncover mind-blowing facts that will change how you see the ocean forever. But first, if you're loving Ocean Week, smash that like button and subscribe for more incredible ocean content that will blow your mind every single week. Today's journey will take us from the deepest ocean trenches to coastal communities, from ancient disasters to cutting-edge warning systems. We'll meet survivors who defied impossible odds, and scientists who race against time to predict these liquid monsters. Are you ready to discover the terrifying beauty of tsunamis? Let's start with a fact that will surprise you. Tsunamis aren't really waves at all, at least not in the way you think about waves. When you see a normal ocean wave, you're watching wind push water around. These waves are maybe 10 feet tall, they break on the shore, and that's it. But a tsunami? A tsunami is a series of extremely long waves caused by a large and sudden displacement of the ocean, with waves tens to hundreds of miles between crests. Here's where it gets incredible. The word tsunami comes from the Japanese characters for harbor, tsu, and wave, nami. But these aren't harbor waves, they're ocean-spanning juggernauts. Picture this mind-bending reality. In the deep ocean, a tsunami can move as fast as a jet plane, over 500 miles per hour. At the deepest ocean depths, tsunami wave speed reaches about 800 kilometers per h, the same as a jet aircraft. That means a tsunami generated off Japan could reach California in less than 10 hours. But here's the truly shocking part. Despite traveling at over 800 kilometers per hour, owing to the enormous wavelength, the wave oscillation at any given point takes 20 or 30 minutes to complete a cycle and has an amplitude of only about 1 meter in deep water. Ships in the deep ocean might not even notice a tsunami passing beneath them. Scientists can calculate tsunami speed using this formula. Take the square root of water depth times 32.2 feet per second squared. In 15,000 feet of water, this works out to almost 475 miles per hour. Now here's where physics becomes terrifying. As the tsunami enters shallower water, its speed decreases, but its height grows dramatically. When they arrive on shore, most are less than 10 feet high, but in extreme cases, they can exceed 100 feet when they strike near their source. But the most mind-blowing recent discovery? Scientists have identified something called meteotsunamis. Tsunami-like waves caused by atmospheric pressure changes that have been observed to reach heights of 6 feet or more, occurring in places like the Great Lakes, Gulf of Mexico, and Mediterranean Sea. Now let's journey through time to witness some of the most catastrophic tsunamis in human history. These are not just statistics. They are stories of human tragedy and survival that changed our understanding of the ocean forever. The 2004 Indian Ocean tsunami, when the Earth shook the world, December 26, 2004. While families were celebrating the holidays, something unprecedented was happening beneath the Indian Ocean. The earthquake had the longest fault rupture ever observed, between 1,200 and 1,300 kilometers, and the longest duration of faulting ever observed, lasting at least 10 minutes. It caused the entire planet to vibrate as much as 10 millimeters. This wasn't just an earthquake, it was a geological monster that literally moved the Earth's axis and shortened the length of a day by microseconds. The resulting tsunami killed over 230,000 people across 14 countries, making it one of the deadliest natural disasters in recorded history. The waves traveled across the entire Indian Ocean. In Indonesia, waves reached 24 meters high. That's an 8-story building. In Thailand, tourists and locals had no warning system, no preparation. Home videos from that day show people on beaches watching the ocean recede, not knowing they had minutes before the wave would return with unimaginable fury. March 11th, 2011. Japan, despite being the most tsunami-prepared nation on Earth, faced nature's ultimate test. The magnitude 9.0 earthquake off Japan's coast generated waves that overtopped seawalls designed to handle the worst-case scenario. The footage is haunting. Black water flowing like a river across farmland, carrying cars, houses, boats, entire pieces of civilization swept away like toys. The tsunami reached 40 kilometers inland, traveled at 40 miles per hour on land, and created waves up to 40 meters high in some areas. But perhaps most shocking was the nuclear disaster it triggered at Fukushima, proving that tsunamis don't just destroy, they can create technological catastrophes that last for generations. November 1st, 1755. It was All Saints' Day, and churches across Lisbon were packed for morning mass. Then the earth shook for 6 terrifying minutes. But that was just the beginning. Within an hour, 3 massive tsunami waves struck Portugal's coast. The waves reached 15 meters high and traveled up to 5 kilometers inland. Ships in the harbor were picked up and smashed into the city. The death toll reached 100,000 people, and the tsunami was felt across the Atlantic, even reaching North Africa. This disaster changed European thinking about natural catastrophes and divine providence. Voltaire wrote about it, philosophers debated it, and it sparked the birth of modern seismology. But tsunamis haven't stopped making headlines. In August 2024, a landslide in Peterson Lagoon, Alaska, generated a tsunami of 17 meters high, approximately 56 feet, showing that these events continue to surprise us. Even more incredible, in 2023, scientists observed a bizarre event where mega tsunamis in an East Greenland fjord shook the entire world for 9 consecutive days. One wave measured 650 feet high, taller than most skyscrapers. In 2018, Central Sulawesi faced a devastating combination when an estimated 4,340 people were killed by earthquake, tsunami, and liquefaction, with about 1,252 people killed specifically by the tsunamis that arrived at high tide. Now let's unlock the secrets of how these liquid monsters come to life. Understanding tsunami generation is like understanding the Earth's most violent temper tantrums. About 80% of tsunamis are born from underwater earthquakes, but not just any earthquake. The sea floor must move vertically, either thrust upward or drop down, displacing massive volumes of water. Picture this: you're in a bathtub, and you suddenly lift up a large section of the bottom. The water has nowhere to go but up and outward. Now imagine that bathtub is the Pacific Ocean, and the bottom that moves is a piece of seafloor the size of California. That's a tsunami birth. The earthquake must typically be magnitude 7.0 or greater, occur relatively shallow, less than 70 kilometers deep, and involve significant vertical seafloor displacement. In the Pacific Ocean, locally damaging tsunamis strike some part every 1 to 2 years on average, with 76% of history's fatal tsunamis occurring there. Here's something that might keep coastal residents awake at night. Landslides can generate tsunamis that are often more destructive than earthquake-generated ones because they can create much taller waves in a focused direction. The 2024 Alaska event showed this perfectly. A landslide created a 56-foot tsunami in a remote lagoon. But landslides can happen anywhere there's steep underwater terrain, which includes most coastal areas worldwide. The Mediterranean Sea is particularly vulnerable to landslide tsunamis. The continental shelves drop off dramatically, creating perfect conditions for underwater avalanches that can generate devastating local tsunamis. Volcanic tsunamis are rare, but incredibly destructive. When a volcano erupts underwater, or when a volcanic island collapses, the displacement can be enormous. The most famous example is Krakatoa in 1883. The volcanic explosion was so powerful, it was heard 3,000 miles away. But the tsunamis it generated killed more people than the explosion itself. Waves reached 40 meters high and traveled 7,000 kilometers across the Indian Ocean. Scientists today worry about places like the Canary Islands, where volcanic activity could potentially cause massive landslides that would generate mega tsunamis affecting the entire Atlantic basin. This is where tsunami science enters the realm of disaster movies, except it's real. When large asteroids hit the ocean, they create tsunamis that can literally reshape coastlines. The asteroid that killed the dinosaurs 66 million years ago likely generated tsunamis thousands of feet high. Computer models suggest these waves would have been tall enough to wash over the Appalachian Mountains. While large asteroid impacts are extremely rare, NASA and other space agencies actively monitor near-Earth objects partly because of the tsunami risk they pose. Climate change has revealed a new tsunami source that has scientists alarmed. The 2023 Greenland event, where mega tsunamis shook the world for 9 days, was caused by glacial processes. Essentially, as glaciers retreat due to warming, they destabilize massive amounts of rock and ice. These glacial tsunamis can occur in fjords, lakes, and coastal areas where glaciers are retreating. As our planet warms, we're likely to see more of these previously unknown tsunami sources. After the devastating 2004 Indian Ocean tsunami caught the world unprepared, the international community built something remarkable: a global tsunami warning system that operates 24/7, 365 days a year. Local and regional tsunamis, with their relative frequency and short impact time, account for 99% of tsunami casualties, which means warning systems must provide alerts within minutes, not hours. The system works like this. When a significant underwater earthquake occurs, seismic stations around the world detect it within minutes. But here's the challenge. Not every underwater earthquake generates a tsunami. Scientists must determine if the earthquake had the right characteristics: magnitude, depth, location, and type of rupture. The real breakthrough came with deep ocean assessment and reporting of tsunamis, DART buoys. These technological marvels sit in the deep ocean, thousands of miles from shore, waiting to detect something that might not even be visible to the human eye. Here's how they work. A bottom pressure recorder sits on the ocean floor, detecting the tiny pressure changes as a tsunami passes overhead. Remember, in deep water, tsunamis have an amplitude of only about 1 meter, but the DART system can detect pressure changes as small as 1 millimeter of water height change. When the bottom unit detects an anomaly, it sends an acoustic signal to a surface buoy, which immediately transmits the data via satellite to warning centers. The entire process takes less than 15 minutes. Modern seismology can pinpoint earthquake locations within kilometers and determine magnitude within minutes. But tsunami scientists need more. They need to know if the seafloor moved vertically. New techniques include moment tensor analysis, which determines the type of fault rupture. A strike-slip earthquake, where plates slide past each other, won't generate a tsunami. But a thrust earthquake, where one plate is pushed up or down, can displace enormous volumes of water. Scientists are also using GPS technology in ways never imagined. During the 2011 Japan earthquake, GPS stations detected that parts of Japan moved 2.4 meters eastward and dropped by over a meter. This real-time geodetic data now feeds into tsunami warning systems. The newest frontier in tsunami prediction involves AI systems that can analyze thousands of variables simultaneously. These systems learn from historical data, satellite imagery, and real-time sensor networks to identify tsunami risk patterns that humans might miss. Machine learning algorithms can process seismic data, ocean buoy readings, coastal sea level measurements, and even social media reports to create comprehensive threat assessments in real time. But the most critical part of any warning system is what happens at the local level. Recent research from the 2024 Japan tsunamis showed that local coastal geography can amplify tsunami heights dramatically. Tsunamis over 3 meters high were concentrated in specific bays due to local amplification effects. Advanced coastal warning systems now include automated sirens that activate based on seismic triggers, cell phone emergency alerts with evacuation routes, digital signs on beaches that display threat levels, community education programs teaching natural warning signs. The human element. Natural warning signs. Technology is incredible, but sometimes the best tsunami warning system is human knowledge. Indigenous communities around the Pacific have passed down tsunami knowledge for centuries. Natural warning signs include ground shaking from an earthquake, rapid ocean recession, the sea suddenly pulling back, unusual ocean sounds, roaring or hissing, abnormal animal behavior. The challenge is education. In 2004, a 10-year-old British girl named Tilly Smith saved hundreds of lives on a Thai beach because she recognized the signs of a tsunami from a geography lesson. Her story shows that knowledge truly saves lives. Scientists are developing even more advanced systems: underwater fiber optic cables that detect seafloor movement, satellite systems that can spot tsunamis from space by detecting subtle changes in ocean height, quantum sensors that might detect gravitational wave signatures from major earthquakes before seismic waves arrive. Dr. Sonali Deraniagala was vacationing in Sri Lanka with her husband and 2 young sons when the 2004 tsunami struck. In her hotel room, she noticed the ocean behaving strangely, pulling back, revealing the seafloor. She convinced her family to get in their car and drive inland. But the wave caught them. Their car was lifted and tossed like a toy. In those terrifying moments, she watched her entire family disappear into the churning water. Sonali survived by grabbing onto a tree, then floating debris, then being rescued hours later. She was the sole survivor of her immediate family. Her story, documented in her memoir, Wave, shows how survival often comes down to seconds and luck, but also the importance of recognizing natural warning signs. Czech supermodel Petra Nemcová was in Thailand when the 2004 tsunami hit. She and her photographer boyfriend were in their beachfront bungalow when the waves struck. The force was unimaginable. Petra was swept away but managed to grab a palm tree. For 8 hours, she clung to that tree with a shattered pelvis and internal injuries, watching debris and bodies float past. Her boyfriend was never found. What kept her alive? She focused on helping others. She spotted a little boy in the water and helped pull him to safety. She says that helping others gave her the mental strength to survive. Her story shows that even in the darkest moments, human compassion can be a survival tool. In Japan, 2011, the town of Minami-Sanriku faced complete destruction. But one building's story became legendary: the 3-story disaster prevention building where 130 people took refuge. As the water rose past the 2nd floor, then the 3rd floor, people climbed onto the roof. The water kept rising. At the peak, only the building's radio antenna remained above water. 50 people clung to that antenna, and the roof edges in freezing water for hours. Against all odds, 130 people survived on that roof. But the real hero was Miki Endo, a 22-year-old emergency broadcast announcer. Even as water flooded the building, she stayed at her post, broadcasting evacuation warnings until the very last moment. Her voice saved thousands of lives in surrounding areas. She didn't survive, but her courage exemplifies how individual actions can save entire communities. In Thailand's Moken community, an ethnic group known as sea nomads, not a single person died in the 2004 tsunami. Why? Centuries of traditional knowledge. The Moken have legends about Laboon, the wave that eats people. When they saw the ocean recede and heard the strange sounds, they immediately headed for high ground. Their children are taught from birth to recognize these signs. Elder Saleh Kalathalai said, "The elders told us that when the water recedes fast and you can hear it, that is the sign of the Laboon coming." In Japan, there's a phrase, tendenko, meaning each person for themselves when it comes to tsunami evacuation. This isn't selfishness, it's practical wisdom. If everyone looks after their own evacuation first, you don't create bottlenecks or dangerous rescue situations. The 2011 tsunami proved this wisdom. In Rikuzentakata, where 1,700 people died, many casualties occurred because people went back to rescue others or retrieve belongings. In contrast, in areas where people immediately evacuated without hesitation, survival rates were much higher. Tsunami survivors share common psychological traits. Immediate action. Survivors don't waste time gathering belongings or questioning warnings. Situational awareness. They notice environmental changes others miss. Helping others. Paradoxically, those who help others often have better survival rates. Mental resilience. They focus on what they can control, not what they've lost. Dr. John Leach, a survival psychologist, notes that in disasters, about 10% of people respond immediately and appropriately. 80% are stunned and wait for instructions, and 10% panic completely. Tsunami survival often depends on being in that first 10%. Hollywood has created some dangerous misconceptions about tsunamis that could cost lives. Myth. Tsunamis look like giant surfing waves. Reality. Most deadly tsunamis appear as rapidly rising water or a fast-moving wall of black water filled with debris. Myth. You can outrun a tsunami in a car. Reality. Tsunamis can travel 40 miles per hour on land, faster than most evacuation traffic. Myth. Swimming underwater will save you. Reality. Tsunami water is full of debris, chemicals, and sediment. It's like swimming in liquid concrete. Myth. Tsunamis only affect coastal areas. Reality. They can travel 10+ kilometers inland up rivers and low-lying areas. Myth. A small tsunami isn't dangerous. Reality. Even a 3-foot tsunami can knock adults off their feet and carry cars. Future threats. What scientists are worried about. The Cascadia subduction zone. This fault off the U.S. Pacific Northwest generates magnitude 9+ earthquakes every 500 years. The last one occurred in 1700. We're overdue, and when it happens, it could generate tsunamis affecting the entire Pacific Rim. Climate change amplification. Rising sea levels mean tsunami waves will travel further inland than ever before. What was once safe elevation might not be safe anymore. Glacial lake tsunamis. As glaciers retreat, they create massive lakes held back by ice or unstable rock dams. When these fail, they can generate devastating local tsunamis. Underwater methane explosions. Scientists have identified massive methane deposits on ocean floors that could potentially explode, generating unexpected tsunamis. Volcanic island collapse. Places like the Canary Islands have unstable volcanic slopes that could collapse into the ocean, potentially generating Atlantic-wide mega tsunamis. The new age of prediction. Artificial intelligence is revolutionizing tsunami science. Machine learning can analyze thousands of earthquake parameters in real-time satellite imagery, can spot tsunamis from space. Social media monitoring helps track wave arrival in real-time. Quantum sensors might detect gravitational waves from earthquakes before seismic waves arrive. Global cooperation, our best defense. Today's tsunami warning systems represent unprecedented international cooperation. Countries that were once enemies now share critical data within minutes of a potential tsunami-generating event. The Indian Ocean Tsunami Warning System, established after 2004, connects 28 countries in a real-time information network. When an earthquake occurs anywhere in the region, all participating nations receive warnings within minutes. As our incredible journey through the world of tsunamis comes to an end, we are left with a profound appreciation for the raw power of our planet and the resilience of human beings who face its greatest challenges. We've traveled from the deepest ocean trenches where earthquakes birth these liquid monsters, to coastal communities where split-second decisions mean the difference between life and death. We've seen how cutting-edge science races against time to provide warnings, and how ancient wisdom still saves lives in our modern world. With 76% of history's fatal tsunamis occurring in the Pacific Ocean and locally damaging tsunamis striking some part of it every 1 to 2 years, this isn't just a story about the past, it's about our future. Climate change is revealing new tsunami sources as glaciers retreat and sea levels rise. Our increasingly connected world means a tsunami anywhere can affect communities everywhere. But we're also more prepared than ever before, with global warning networks, advanced science, and growing public awareness. The heroes of tsunami science aren't just the researchers in their labs or the emergency managers at their posts. They're also people like you who take the time to learn about these natural phenomena. Knowledge is the best defense against nature's fury. Remember the lessons from today. Trust the natural warning signs. Ground shaking, ocean recession, unusual sounds. When in doubt, evacuate immediately to high ground. Don't return to coastal areas until authorities give the all clear. Have an evacuation plan if you live in or visit coastal areas. The ocean that gives us life can also take it away. But understanding tsunamis, respecting their power while not living in fear, makes us better prepared for whatever our dynamic planet might throw at us. If this episode has opened your eyes to the incredible science of our oceans, smash that like button and subscribe. Next week, we're diving into another ocean mystery that will absolutely blow your mind. The creatures living in our deepest ocean trenches, where the pressure could crush a human instantly, but life still finds a way to thrive. What aspect of tsunami science fascinated you most? Drop your thoughts in the comments below. Did you learn something that could save your life or someone else's? Share this knowledge. It might be the most important thing you do today. Until next time, keep exploring, keep learning, and remember, our planet's greatest forces are also its greatest teachers. Thanks for joining us on this incredible journey into the science of tsunamis. Stay curious, stay safe, and we'll see you next week for another mind-blowing episode of Ocean Week.